A prime number is a positive integer, with no divisors other than 1 in itself, excluding 1.
I don't get it.
Okay, said differently, a prime number is a natural number greater than 1, that cannot be formed by multiplying two smaller natural numbers.
Okay, and a natural number that is not prime, is?
A natural number, greater than 1, that is not prime, is called a composite number. For example, the number 5 is prime because the only ways of writing it as a product involve 5 itself. Whereas, the number 6 is composite, because it is the product of two numbers that are both smaller than 6.
So, a prime number is a number, greater than 1, that is not a product of two smaller natural numbers.
That's exactly what I said.
No, that's not exactly what you said. That's what I said.
Okay. Hello and welcome back to my channel. Today, we're writing a method that determines if a given sentence is prime, almost prime, or composite. A sentence is prime if all the word values within the sentence are prime. The word value of a sentence is established by summing up all the numeric values of every single character, excluding spaces and punctuation. A value from 1, A, to 26, Z, is given to letters, while numbers have their literal values from 0 to 9. A sentence is almost prime if, after a single removal of any of the words, the new sentence value is a prime. Our method should return the word that required removal to make the sentence prime. If more than one word can be removed to obtain a prime value, it should return the first encountered in the original sentence. A sentence is composite if more than one word removal is necessary to make the new sentence value prime, or if none is possible.
The solution to this problem consists of a linked hash map, which is needed in order to maintain the original order of the values it will contain, and a string tokenizer. First, a string variable named alpha is defined, containing capital letters of the English alphabet. Next, a primitive integer variable named sum is defined and initialized to 0. Next, the string tokenizer is instantiated, with the value of the incoming string, along with the delimiter of a space, and assigned to the variable tokenizer. Next, a linked hash map is instantiated and assigned to the variable map. While the string tokenizer contains tokens, all punctuation and spaces are removed from each token, and the result is assigned to the variable original word. Next, the original word is converted to uppercase, and the result is assigned to the variable word. Next, a primitive integer named word sum is initialized to 0. Next, a loop is initialized to execute until the length of the word has been reached. For each character in the word, if the value is a digit, the word sum variable is incremented by the literal value of the digit, otherwise, the word sum variable is incremented by the index position where the character is found within the English alphabet, +1. Once all characters have been evaluated, resulting in the word sum variable containing the sum of all characters in the word, the sum variable is incremented by the value of word sum.
The variable sum represents the sum of all character values within the entire sentence. The variable word sum represents the sum of the character values of a single word.
Next, the linked hash map is populated with the original word as the key, and the value of word sum as the value. Once all tokens of the string tokenizer have been processed, we can determine if the sentence is prime or not. To do this, we make a call to the helper method, isPrime, passing it the sum of the characters within the sentence.
One simple, but slow method of checking the primality of a given number, num, is called trial division, which tests whether num is a multiple of any integer between 2 and the square root of num. Inside the isPrime method, we evaluate whether the incoming number, num, is 2 or not. If it is, 2 is prime, and true is returned to the calling method. Otherwise, if the number is less than 2, or the number is divisible by 2, the number is not prime, and false is returned to the calling method. Otherwise, a loop is initialized that starts at the value of 3, and stops when the square root of the iteration counter is greater than the incoming number. For every iteration of the loop, the value of I is incremented by 2. If the incoming number is divisible by the iteration counter, I, the number is not prime, and false is returned to the calling method. If the loop completes successfully, num is prime, and true is returned to the calling method.
Back inside the calling method, if the call to is prime returns true, the string prime sentence is returned to the caller, otherwise, we set up a loop to retrieve each word in the sentence. For each word in the sentence, we determine if, after removing its sum of characters from the total sum of characters in the sentence, we have a prime, the string almost prime sentence, along with the original word that was removed from the sentence, is returned to the caller. If the loop completes successfully, indicating we were unsuccessful at finding a prime by removing each word in the sentence, the string composite sentence is returned to the caller.
Now, for a bit of trivia, how many decimal positions does the largest prime contain? Thank you for watching this video, and remember to like, share, and comment. We look forward to seeing you in the next episode of
Wow! How'd you code that?